Hi guys, welcome to the day 6 of 100 days quant series. So in this video we will be discussing 5 questions from permutations and combinations and probability. Right. So whenever you see a question on the screen, please pause the video, try solving that question. Once you're done solving, you can resume the video. Now coming to the first question, how many possible values of n will make 13cn less than 13cn plus 2. Now my first observation, this has to be non-negative. So n should be greater than or equal to 0. So n can take values like 0, 1, 2, 3, so on. Right. And that should be strictly less than n plus 2 should be strictly less than or equal to 13. Right. Now let's expand 13cn. This would be 13 factorial by 13 minus n factorial into n factorial. This should be less than 13 factorial by 13 minus n plus 2, 11 minus n factorial into n plus 2 factorial. But this is nothing but expansion of NCR. Right. Now I can cancel 13 factorial in the numerator. Right. Now I can cancel n factorial from n plus 2 factorial. So you will be left with n plus 1 into n plus 2. Because n plus 1 factorial is nothing but n factorial into n plus 1. N plus 2 factorial would be n factorial into n plus 1 into n plus 2. Now coming to 13 minus n factorial and 11 minus n factorial. Now I can cancel this and you will be left with 12 minus n into 13 minus n here. Right? Now 1 by 12 minus n into 13 minus n should be less than 1 by n plus 1 into n plus 2. Now let me cross multiply. So you will be having n plus 1 into n plus 2 less than 12 minus n into 13 minus n. So on expansion, what do we have? N square plus 3n plus 2 should be less than n square minus 25n plus 156. Right. I can cancel n square on both sides. Now shifting minus 25n to left hand side, we'll be having 28n should be less than 156 minus 2, 154, or n should be less than 154 by 28. 28 5s 140, 14 by 28, 1 by 2, 0.5. So this is 5.5. So n should be less than 5.5 and n has to be greater than or equal to 0. And n can take only the integer values. You cannot have 13c 1.5. Right. So what are the integers greater than or equal to 0 but less than 5.5? 0, 1, 2, 3, 4, 5. How many values do we have? 6. So option C should be the answer for this question. Now coming to the second question, the sum of 5-digit numbers in which only odd digits occur. So we have digits 1, 3, 5, 7, 9, 5-digit numbers. We are asked to find the sum without any repetition. Right. Now to answer these types of questions, we have a simple formula. Right. And that too, all the digits should be different. There should not be any repetition and 0 should not be among the digits. If that's the case, you can apply this formula. See how many digits do we have? 5 digits. So I'll place 1, 2, 3, 4, 5. 5 ones. 11,111. Right. Now since we have 5 digits, n minus 1 factorial. If there are n digits, you should be multiplying this with n minus 1 factorial. We have 5 digits. So we should be multiplying with 4 factorial into 4 factorial into sum of all the digits. 1 plus 3 plus 5 plus 7 plus 9. Now 1 plus 3 4 plus 5 9, 9 plus 9 18, 18 plus 7 25. So this should be nothing but 11,111 into 24 into 25. Now this should be 66 lakh 66,600. Option D should be the answer for this question. Simple formula to remember. Now coming to the third question, the number of words that can be formed out of the letters of the word committee, COMMI, COMMITTEE. Now in these types of questions, now first let's count the number of letters 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 letters, so you'll be having 9 factorial. Now by, do we have any letters that are being repeated? Yes, we have two M's, we have two T's, we have two E's. Right, since we have two M's, you should be having 2 factorial, 2 T's, 2 factorial, 2 E's, 2 factorial. So 9 factorial by 2 factorial into 2 factorial into 2 factorial. So 9 factorial by 2 factorial whole cube. That should be your answer. Now coming to the next question, the number of ways of selecting exactly 4 fruits out of 4 apples, then you have 5 mangoes, and you have 6 oranges. Now from these, you need to select exactly 4 fruits. Are we given with any condition? No. So those 4 could be apples or mangoes or oranges, and you can have n number of apples, n number of oranges, n number of mangoes. Right. Now, let's start with, among those 4 fruits, there are no apples, right? 0. So all those 4 should be either mangoes or oranges, right? Now, one possibility is all of them being mangoes. So if all 4 are mangoes, you have 0 oranges. But this is when there is no apple, right? Or you can have 3 mangoes, 1 orange, or 2 mangoes, 2 oranges, 1 mango, 3 oranges, or 0 mangoes, 4 oranges. Now when I assume that there are no apples, right, now you can select those 4 fruits in how many ways? 1, 2, 3, 4, 5. 5 possible ways, right? Clear? Now let me consider that there is one apple. Out of 4 fruits, one is apple. So you need to select 3 more. Right. Now, out of those 3, all 3 can be mangoes. Then you won't be having any oranges. 3, 0. 2 mangoes, 1 orange. 1 mango, 2 oranges. 0 mangoes, 3 oranges. So, when there is exactly one apple among those 4 fruits, you have 4 ways to select the remaining 3 fruits. Now, if I consider that there are 2 apples, right, then 2 mangoes, no oranges, 1 mango, 1 orange, 0 mango, 2 oranges. So how many ways? 3 ways. Then there are exactly 2 apples. Now, if I have 3 apples, right? Now, the one that could be either mango and no and 0 oranges, or 0 mangoes and 1 orange. So you have 2 ways. Now, if all 4 are apples, no orange, no mango, so you have 1 way. Right. Now, in total, in how many ways can we select exactly 4 fruits? 5 plus 4 plus 3 plus 2 plus 1. Right. So that has to be 15. So the value is 15. Right. Now 10C1 is 10. 15C1 is 15. 15C4 is not 15. So the answer for this question should be option B. Now coming to the fifth question. 2 cards are drawn at random from a well shuffled pack of 52 cards. What is the probability that either both are red or both are queens? Now we know that there are 26 red cards and there are 4 queens. Right. Now we need to pick 2 cards, and those 2 must be both being red or both being queens. Right. Now let me consider this. Both being red, right? So from these 26 cards, you are picking 2. So 26 C2, or so plus 4 queens. Out of these 4 queens, you need to pick 2, right? Now let us consider this case where out of these 26 red cards, you are picking 2 red cards. So they can be queen of hearts and queen of diamonds, right? And from these 4 pins, you're picking 2, and there also it can be what, queen of hearts and queen of diamonds, right? So we have the same case repeating twice, so I have to subtract 1, because picking queen of hearts and queen of diamonds is here as well as here, right? Since it is being repeated twice, I'm subtracting that, right? By, what is the total number of outcomes? From 52 cards, you are picking 2. Now 26 C2, that would be 13 into 25 plus 4 C2, 6 minus 1, 5 by 52 C2, that would be 26 into 51. Now I can take 5 common. If I take 5 common, you have 13 into 5, 65, 65 plus 1, 66 by 26 into 51. Right. Now, what do we have? 3 22s, 3 17s, 2 11s, 2 13s. 5 into 11, 55 by 13 into 17. 170, 170 plus 51, 221. So the answer for this question should be 55 by 221.